A natural gas pipeline, 210 km long, consists of an inlet steam at A and delivered at B and C. The pipe is has a nominal diameter of 400 millimeter, 10 millimeter wall thickness. Now, at A, the gas entered at a speed at a flow rate of 3.5 million cubic meter per day. So let's start with our drawing. Now, at A, this is at B. Now, at A, it flows in with 3.5 metric million meter cube per day. Now, they said at point B, which is 20 kilometers, and at C, which is 100 kilometers. That means from A to B is 20 kilometers, and from B to C is what? This is 80 kilometers. So since at C is 100 kilometers from A, then that is it. So now gas is delivered at 0.5 million cubic meter per day and 1.0 million cubic meter per day respectively. So that means it is delivered. So now when it is delivered, that means gas goes out like this, delivered at B and C. So at B it was delivered at 0.5 metric meter cube per day. Let me see, it was delivered at that. Then at C it was delivered at one. It was delivered at 1.0 million meter cube per day. Now, so when as it's flowing from this, so if 0.5 is out, from here you have 3. Now if here now it will be flowing at what? 3.0 million meter cube per day. Now since 1 now left this, you now have from C to D. Now let's see, at D, which is 150 kilometers, gas enters a branch pipe DF. Now a branch pipe DF. Now this is our F. Now gas enters a branch pipe DF. So it delivers at F. So now it delivers at what rate? So it delivers at a flow rate of 1.0 meter 1.0 million meter cube per day. So now you have 1.0 million meter cube per day. Now, from here to here is what? 50 kilometers. Since from A to D is 150 kilometers. So if you add up all this, you have 150 kilometers. Now let's say the remaining gas volume of 1 is delivered at pipe terminal E. So now since 1 left here, so this is 3. So here will be 2.0 million meter cube per day. Now, and 1 is leaving. So what will be left now? Go to E, which is the terminal point, will now be 1.0 million meter cube per day. So we now have, now they said the remaining gas volume of 1.0 million meter cube per day is delivered to the pipe terminus E. All stream of gas can be assumed to have a specific gravity of 0.5 g. So they have a specific gravity of what? 0.58. Now, and a viscosity of 0.00012 pus. Now, a viscosity of 0.00012 pus. Now, let's see. The pipe absolute roughness is 0.015. Absolute roughness is 0.015 millimeter. Now, throughout the system, that is what it is. So now, assuming a constant gas flow temperature of 15 degrees C. So the constant gas temperature is 15 degrees C, so which is 273 plus 15 equal to 288 Kelvin. Now we are converting it from C to absolute temperature. So now the base pressure and the base temperatures of 101 kilopascal and 15 degrees Celsius respectively. So that means we have the base pressure to be 101 kilopascal. We also have the base temperature of 15 degrees C, which is what? 288 Kelvin. Now using a pipeline efficiency of 0.95, so our E is equal to 0.95. Now, and constant compressibility factor of 0.88 throughout. Neglect elevation difference along the pipeline. Now, using the Panhandle B equation, calculate the pressure along the pipe at A, B, C, and D for a minimum delivery pressure of 30 bar at terminus E. What is the delivery pressure of the gas at the end of the branch DF? So, what pipe diameter is needed for the branch DF if the delivery pressure required at F is 40 bar? Now, let's So the Z is equal to what? 0.88, and the nominal diameter of this whole pipe from A to E is 400 millimeter, while the thickness is what? 10 millimeter. Now for DF, the nominal diameter for DF is equal to what? 200 millimeter, and the thickness of DF, the wall thickness is 6 millimeter. Let's look at the 200, nominal diameter 6, wall thickness is 6, okay, 6 millimeter wall thickness. Now let's go there. The length of the pipe DF is what? 10 kilometers. Now, since the total length of A to E is 210, so from at this point you have 150 kilometers. So if you minus 210 from 150 kilometers, you have 60 kilometers. And now we have gotten the length from A to B, B to C, C to D, D to E. Let me just circle these alphabets. So we are given the pressure at what? E, which is P subscript E, to be 30 bar. So P subscript E is what? 30 watts bar. Now we need to convert this 30 bar to kilopascal. So to do that, you have 30 bar times, since 100 kilopascal is equivalent to 1 bar. So if you cancel out these bars, you have 3000 kilopascal equal to 30 bar. So that is for P. So we're going to be using this to calculate our values. So now let's go back to, now I can now say from here to here, I can just put this to be 10 kilometers. So from here to here, 10 kilometers. So I don't need to bother myself with putting that. Let me now put the nominal diameters to be equal to 200 millimeter. The thickness here is 6 millimeter. So from A to E is the same, which is 6. Let me go back. Is that 2? So this is where they say the pipeline is, the nominal diameter is 400, and the wall thickness is 10 millimeter. So now let's calculate. They say we should use Panhandle B equation. So now we're going to use Panhandle B equation to solve this particular problem. Now let's go to the next page. Now for Panhandle equation, you have the flow rate to be equal to 1.002 times 10 raised to power minus 2 E, bracket open, the base temperature divided by the base pressure, raised to power 1.02 times, bracket open, P1 square minus P2 square divided by G raised to power 0.961 times the the gas temperature times the length, the pipe segments times the compressibility factor, bracket close, all raised to power 0.51 times internal diameter raised to power 2.53. Now, where pay very much attention where the flow, where the gas flow rate this one a standard meter cube per day, then E will now be pipe efficiency. So this is gas efficiency, this is a pipe efficiency. Then the next one you have PB, which is what? The base pressure. And this base pressure is in kilopascal. This should be absolute. Oh, this is absolute already. I don't need to write it. So we also have the base temperature. The base temperature. So we say the base temperature, that is in Kelvin, which is 273 plus degrees C, if you're given in degrees C. So that is it. Then TF is what we could call the average gas flow temperature. So this is in Kelvin. Now we also have the that one. This is P1, which is the upstream pressure. This is in kilopascal, absolute. Now you have P2, which is the downstream pressure. In kilopascal, it should be absolute again. So now we have, I need to put everything here. You have another one, which is the length, which is L, which is the length of pipe segments. So this is in kilometer. This is in kilometer. You have the Z, which is what? The gas compressibility factor. So, and this is dimensionless. So this is a compressibility factor and the gas flow temperature. Very important. And the gas at the flowing temperature. or say gas flow temperature or the flowing temperature. So now that is it. So now we're going to be making use of this formula to solve for the upstream pressures at each segment of the pipeline. So now first we need to calculate the internal diameter of the pipeline. So we have the nominal diameter of the pipeline to be 400 millimeter. We have the pipe thickness to be 10 millimeter. So the internal diameter will be the nominal diameter minus 2 times the wall thickness. So we have 400 minus 2 times 10. This will be 400 minus 20. So this will give us 380 millimeter. So having gotten this, we now have to employ the flow equation. So now our first point is we are given the downstream for DE, we are given the downstream pressure, which is PE. We're looking for the upstream pressure, which is D. Now our PE is given, we're looking for D. Now we know the length, which is 60 kilometers. We know the flow rate, which is 1. Now let's go back. Now let's make use of the panhandle B equation. Now the panhandle B equation will have the flow rate to be equal to what? 1.002 times 10 raised to power minus 2 E brackets TB all over PB raised to power 1.02 times PD square minus PE square divided by G raised to power 0.961 TFLZ all bracket close all raised to power 0.51 times D raised to power what 2.53. Now let's say the length DE is what 60 kilometer. The flow rate for DE is what 1.0 times 10 raised to power 6 meter cube, standard meter cube per day. Now, so we're going to make use of this. So now we have 1.0 times 10 raised to power 6 equal to 1.002 times 10 raised to power minus 2 times E, which is 0.95 times T, that is a base temperature, which is what 288 divided by 101 all raised to bracket close all raised to power 0.02 then 1.02 times bracket open P D square minus PE square divided by G raised to power 0.961 TFL LDE times say all raised to bracket close all raised to power 0.51 times d, which is what? 380 raised to power 2.53. So now, since we have gotten up to this point, we can make the whole of this the subject of formula. So to make it subject of formula, we use this expression here and here. We divide both sides of the equation with this and this, so that we're now left with this. So now that is what we're going to do. That is what we are going to do. So that means p d square minus p e square divided by g raised to power 0.961 tf lde z all raised to power 0.51 will now be equal to 1.0 times 10 raised to power 6. Let's see, divide by this. Let me see again. Divide by 1.002 times 10 raised to power minus 2. Divide by this. So divide by 0.95. Now divide by the whole of this. So if you divide by the whole of this, this will reverse in that expression. So you now have times 101 divided by 288 all raised to power 1.02. Now times, now we now divide by this. So now we have times 1 all over 380 raised to power what? 2.53. So this is what we have. Now we are going to make use of our calculator to solve for this particular expression. So now that is what we're going to do now. So I'll make use of my calculator to do that. So you can take this moment and also use your calculator to calculate, to compare what I will get with what you have. So because I might make computational error during the use of my calculator. So now let's calculate. Now we have 1.0 times 10 raised to power 6 1.0 times 10 raised to power 1.0 times 10 raised to power 6 divide by 1.002 times 10 raised to power minus 2 divide by 0.95, then times bracket open 101 divide by 288 bracket close. Now raised to power 1.02 times 1 divided by 380 raised to power 2.53. So what is the answer? So what we have here is what we have here is 10.724. What we have is 10.724. 724 683 589 22. So this is what we have. So now, so that means PD square minus PE square divided by G raised to power 0.961 TF LDE Z raised to power 0.51 is equal to 10.728. 0.728. So now we can now remove this power here. To remove this power is to multiply the powers of both sides by 1 all over 0.51. So we multiply the powers here, which is 1 multiplied by 1 all over 0.51. So this will cancel out. You are left with PD square minus PE square divided by G raised to power 0.961 TF LDE Z equal to 10 raised to 10.72468358922 raised to power 1 all over 0.51. So now let's find, say, raised to power bracket open 1 divided by 0.51 bracket close. Now this will be equal to, this is equal to it should be equal to 104.799 then 708. So this is 211 211.05. So that is it. So now to make PD square minus PE square subject to formula, we multiply both sides by this expression, by this denominator. So now we have PD square minus PE square equal to what? 104.799 708.211.05 times G is 0.58 raised to power 0.961 times TF is 288 times DL, which is 60 kilometer, times Z, which is 0.88. So now that means our PD square will now be now let's clean this, let's erase. No, let's calculate this now. We now see times 0.58 raised to power 0.961 times times 288 times 60 times 0.88 equal to so this whole thing is equal to what? Is equal to 944.539 399 04617. So that means PD square will now be equal to this plus PE square, and PE is 3000 kilopascal square. So that is it. So now we are going to look for PD. So PD will now be equal to this value plus 3000 square. So that is what we're going to do. So using our calculator, we now say plus 3000 square 3000 square equal to so that means PD square is equal to 3 is equal to what? Now let me just say PD. Now let's look for the square root of this value. So the square root will give us what? Will give us 3 7 3753.5 kilopascal absolute. So this is what we got for is this 31 or 37? So this is what we got for the PD. Let me just use me. So okay, this is 3-1, not 3-4. So it's 3-1, not 3-7. So it's 3-1. So let me just erase. Oh, I didn't see properly, so that was why I wrote 3-7. So it's 3153.5. So I've gotten the pressure at D. Now there's something I want to do. Let me go to so we now have our PD to be equal to 53153.5. So now let's solve for PC. So let's solve for PC. So since we've gotten this, the flow rates of CD, the flow rate of CD in section CD is what? Section CD is 2. We're going to use the 2 is 2.0 times 10 raised to power 6. The length of the pipe segment there is 50 kilometer. So we're going to use the length of CD to be 50 kilometers. So what we're going to do next is to now make use of the panhandle B equation, which is for CD to be equal to 1.002 times 10 raised to power minus 2 times E times the base temperature, which is 288, divided by the base pressure, which is 101, raised to power 1.02 times bracket open pressure at C square minus pressure at D square divided by G raised to power 0.961 times TF times LCD times Z raised to power 0.51 times D raised to power 2.53. So but D is the same, which is 380. So for us to solve, to make this a subject of formula, we have P C square minus PD squared divided by G raised to power 0.961 times TF times LCD times C is equal to all raised to power 0.51 is equal to what? Q, which is 2.0 times 10 raised to power 6 divided by 1.0 0.002 times 10 raised to the power minus 2 divided by 0.95, which is our E, times, if this whole thing divides this, you have 101 divided by 288 raised to power 1.02 times 1 all over 380 raised to power 2.53. Oh, so the whole, making this left hand side the subject of formula, we have this to be this. So now this will be equal to, let's now make use of our calculator here. I want to make use of online calculator. So I have 2.0 times 10 raised to power 6 divided by 1.002 times 10 raised to power minus 2 divided by 0.95. Now let's see. Now divide by, now I will now say times bracket open 101 divided by 288 bracket close raised to power 1.02. Now times 1 divided by 380. Okay, no. So just times no. Now times 1 divided by 380 raised to power 2.53. So this will now be equal to this. So it's equal to 2.1 is equal to 21.449. So we have gotten this. So now let's, okay, we have gotten the whole of that to be 21. To be 21. Let me write it down. I have 21.449,325,170.45. So let's go back. So we have 21.449,325,170.45. Now the next move is, now I want to make this expression inside this bracket to be subject to formula. So now for me to do that, I'll multiply the powers by 1 all over 0.5. So meaning that PC minus PD squared divided by G raised to power 0.961 times TF times LCD times Z will now be equal to 21.449 will now be equal to 21.449,325,170 times 4 not times 45 all raised to power 1 all over 0.51. So now I also need to say PC square will now be PD square plus 21.449,325,170.45 all raised to power 1 over 0.51 times G, which is 0.58 raised to power 0.961 times 2088 288 times LCD, which is what, 50 kilometers, times Z, which is 0.88. So let me see CD. Okay, now let me PC square is equal to C is equal to D, which is 3153.5 square. Let's see 0.5, yes, square plus the whole of this, which is 21.449,325,170.45 all raised to 1 all over 0.5 times 0.58 raised to 0.961 times 288 times 50 times 0.88. So now PC will now be the square root of the whole thing. So now let's work it out. Let's work it out. So now I will now have this whole thing. So I will now say raised to power the answer raised to power bracket open 1 divided by 0.51 bracket close. So we have what equal to 400 and something times the whole of this times what 0.58 raised to power 0.961 now times 288 times 50 times 0.88. So this will be what equal to what? So this is equal to this equal to this. So now we now add we now add we add this we add this. So now we say 3,153.434,562,4095 square. So we square this. If we square it, we say equal to what? 6. So now The next thing we're going to do, we say the square roots of the answer, which is this final answer, is equal to what? So we have 3606. Let's write it down. So we have 3606.51 kilopascal as our pressure at C. So this is a pressure at what? C, 3606. So let's go there. So we have our pressure at C to be 3606.51 kilopascal. Now the pressure at B, we're going to calculate that now. Since we have gotten the pressure at C, the pressure at B will now be, using the same formula now, we now have to go back. Here is 3. Since here is 3, we can now use, for 1, we have what? We have that expression to be 10, to be this. For the flow rate of 1 times 10 raised to the power 6, you have 10.73 this. So for 2, if we multiply this by 2, this value here, by 2, we will have the same thing. Let me see. We'll have the same expression. Let's see. We have this 21 point. So now we can use this value for 1 to solve for. If you have, let's say you have this one to be 3, this one to be 3.5. So if you just multiply, like 0.5, you multiply by 1, you multiply, get the same value. So let's see how we have this. So now let's work it out. Now 10.72. Let me see. Let's go back to our calculator. Now let's look at the history. We have this to be, now we have this. So now let's say 2 times 10.7246625852. This will give us 21.449352. So when you go to this, you'll see it's the same thing, 21.44935210 and 45. So that is it. So now we're not going to calculate for so much. So what we're going to do is we're going to make use of this expression here. We can just copy. This is for 1. I can just copy as let me copy. Let me see if I can use it. Now let me say for 3, say 3. Okay, no. Let's say 3 times, let me paste. Let me see whether it will work. Okay, copies a whole. So now we'll just delete this. So for 3, we have this. For 3, we have this value. So this is the value we're going to be using now. So we have similar, because the whole system is constant. So if you just like if we use 2 here, we got this. So that means when we change to 3, we're going to get that value there. We're going to have this value here, this same value. So now let me see. Let me see if I can copy. Okay, no. So I can copy. Okay, supposed to copy this answer. Okay, let me see if I can copy the answer here. No, cannot. All I do is to write it down. Let me just minimize. So can I? No. So let me just expand. So that means for 3, we are going to be making use of this. So now let's now begin. Let me write this down. Let me write this down. Let me write this down. Let me write it down. This is for 1. For 1, we have 10 point what? 724 6625 8522. So that is what we're going to be using now. So that means, so since we have our pressure at C, so pressure, so since the flow rate at BC is the flow rate at BC is 3.0 times 10 raised to power 6, 3.0. So we're going to use that expression now. Now we have the flow rate to be equal to 1.002 times 10 raised to power what? 10 raised to power 10 minus 2 times E, which is 0.95, times this is 288 divided by 101 raised to power 1.02 times P B raised to power 2 minus P C squared divided by G raised to power 0.961 times TF times LBC times Z is equal raised to power 0.51 times D, which is 380 raised to power 2.53. Now for 3, now we'll make the whole of this subject of formula. That means we have PB squared minus PC squared divided by G raised to power 0.961 TF else BC Z is equal to, okay, making the whole of this 0.51 is equal to Q, which is 3.0 times 10 raised to power 6 divided by 1.02 times 10 raised to power minus 2 times 0.95, okay, then times 101 divided by 288 raised to power 1.02 times 1 all over 380 raised to power 2.53. Now we know if here is 1, we have now this whole thing is the same thing as saying 3 times 1, 1.0 times 10 raised to the power 6. So that means if here is 1 and we have a particular value, so 3 times that particular value, which is 10.7, 10 points what, 724, 724, 662, 662, 662, 5, 8, 5, 8, 5, 2, 2, 5, 8, 5, 2, 2. Okay. So if we multiply this by 3, because the whole of this, if you put 1 here, the whole of this is this expression, so times 3. So that means for 1, we have this. So if you multiply it by a factor 3, you have this whole expression to be equal to that. So now let's do that. What will we get? Let's write it down because I've calculated it before. So we have 32.17. Let me write it down. So we have what? 32.173,987,7557. So now, since we have gotten this, so we are going to make use of it now. So we have this time this to be 3 times 10.7, this to give us what? 32.173,987,7557. So that is it. Now for us to get our PB, we are going to make use of, say, now PB square will now be PC square plus 32.173,987,7557 all raised to power 1 all over 0.51 times 0.58 raised to power 0.961 times 288 times. Now what is the length? Let me say BC. BC is what? Like 80. BC is 80 kilometers. Okay. So BC is 80 kilometers times 0.88. So this is what we're going to do now. And our BC is what? 3,606.51 square plus the whole of this. So now plus bracket open 32.173,987,7557 raised to power 1 all over 0.51 times 0.58 raised to power 0.961 times 288 times 80 times 0.88. So now let's make use of our calculator. So let me minimize this. Let me minimize it. We are Now making use of this one. So we'll now say 3606.510762.70508 square plus. Now you say plus this is 32. Okay, we have it here. We have this, which is, we'll now say bracket open 32.173,987,755.7. So say bracket close, we'll say raised to power what, bracket open 1 divide by 0.51 bracket close. Now we'll now see times 0.58 raised to power 0.961 times 288 times 80, which is the length, times the gas compressibility factor, which is 0.88. Now this should be equal to what? Now this is what we have. Now let's say the square root of this answer is equal to what? So we have 4,884.5 or 0.6, sorry. So that is our final answer. Let me write it down. We have, that means the pressure at B will now be 4,884.6 kilopascal. Let me just write it in full. 488.563,492,529. So now that means PB square. So PB will now be equal to what? 4,884.563,449,252,9. So we have PB to be equal to 4,884.6 kilopascal. Now let's calculate for our pressure at what? Let's calculate for pressure at A. So PA square will now be equal to PB square plus. Now we know how to find this inside the bracket, this value inside the bracket. So we'll just say 1 all over 0.51 times this 0.58 raised to power 0.961 times 288 times, now the length of the segment, which is what? Which is 20. So from here, from A to B is 20. So over here is 3.5. So we're going to use 3.5 to get that value there. So here is 50 and 20 kilometer times 0.88. So now we know this PB to be this whole thing. So to get this value, we multiply the value for 1 by 3.5. So the value for 1 is 10.724, 10.724, 724, 522. So we multiply 3.5. So because since we have 3.5 million metric cube per day now, and 3.5 metric cube per day is equal to 3.5 times 3.5 times 1.0 metric a million metric cube per day. So now that is how we got this. So this is for 1. So for 3.5, we multiply 3.5 with this to get this. So now that is what we're going to do. Now let's make use of it. Now let's make use of this expression. Now let's go back to the calculator. So we have gotten this value. We're going to use it here now. So I'm going to say we're going to say 488.563563,449,2529 square plus square plus bracket open 3.5 times what? 10. Let's see. The value for 10 is no more again. Let me see. Hey, let's look at history. Okay, look at the value here. This is it. So we're going to use this. We're going to use this value now. So we have 10 0 point what 72466258522 bracket close raised to power bracket open 1 divided by 0.51 bracket close then times 0.58 raised to power 0.961 times 288 times 20 times 0.88. So that is it. Let me see. 20 is okay, correct. So it's okay. Let's work it out. So it's equal to this. So now let's now calculate for P at A. There is a pressure at A. So we now find the square root. Okay, no. Now just equal to this. We find the square root of this answer. This will give us what? 5,246.85. 5,246.85. So let me write it down. So that is 5,246.8 kilopascal absolute. So that means the PA will now be 5,246.8 kilopascal absolute. So this is for the pressure at what? A. Now there is a question there that we were asked to solve. Now they were asked to say, they said, what is the delivery pressure of gas at the end of the branch, at the end of the branch DF? So now DF, we know the flow rate, which is 1. We know the length 10 kilometer, which is this. We know the flow rate, we know the outer diameter, we know the thickness. So now let's work it out. Now we know the pressure at D. The pressure at D is 1. It's 3,153.5. Let's see, okay, look at it. 3,153.5 kilopascal absolute. So now let's use it to work it out now. So at DF, we know the flow rate to be, that is DF flow rate to be 1.0 times 10 raised to power 6 meter cube per day. Now we know the length of DF, the length of the pipe segment to be what? 10 kilonewton. Now we know the nominal diameter to be 200 millimeter. We know the thickness, the wall thickness to be 6 millimeter. Now throughout the system, we're using the same gas gravity, we are using the same gas compressibility factor. So now the flow rate, which is equal to 1.002 times 10 raised to power minus 2 times E, which is the same thing as 0.95 times 288 divided by 101 raised to power 1.02 times the pressure at D minus the pressure at D square minus the pressure at F square divided by G raised to power 0.961 times TF times the length of what? DF times C, all raised to power 0.51 times the diameter. Now let's calculate the diameter D, the internal diameter D, which is the nominal diameter minus 2 times the thickness. So you have 200 minus 2 times 6, which is 200 minus 12. So this will give us 188, should be 188 millimeter. So this will give us 188 millimeter. 188 millimeter. So this is 188 millimeter. So the D now here is 188. So you now say 188 raised to power what? 2.53. So this is the one we're looking for. We can now say PD square minus PF square divided by G raised to power 0.961 times TF times LDF times Z is equal to what? All raised to power 0.51 is equal to this flow rate, which is 1.0 times 10 raised to power 6 divided by 1.002 times 10 raised to power minus 2 divided by 0.95 times 101 divided by 288 raised to power 1.02. Now times 1 all over 188 raised to power 2.53. So let's calculate this. Let's solve for this. Let's now make use of a calculator. Only what is different now is this. I can use ratio proportionality to get that, but let me not go through that route. Let me just calculate. Let's use our calculator to calculate. So now we have what we have here is 1.0 times 10 raised to power 6 divided by 1.002 times 10 raised to power minus 2 divided by 0.95 times bracket open 101 divided by 288 bracket close raised to power 1.02 times 1 divided by 188 raised to power 2.53. Now let's look at it. Now. Let me check that is it now. So that is it. I will now say equal to this. Go to what? So this is what we have here. So we have 63.6. Let me just write it as 63.6. So the whole of this is what? 63.6. Now let's go here. We have PD square minus PF square divided by G raised to power 0.961 times TF times LDF times Z. This will be equal to 63.6 raised to power 1 all over 0.51. So making PF square subject of formula, we have PD square minus 63.6 raised to power 1 all over 0.51 times G, which is the gas gravity, 0.58 raised to power 0.961 times 288 times LDF is 10 kilometer times 0.88. So we have our delivery pressure to be what now? Let's go back there. Let's now work it out. So our PD is what? Is 3153.5 square minus 63.6 raised to power 1 all over 551 times 0.58 raised to power 0.961 times 288 times 10 times 0.88. So this is how we solve here. Let's use our calculator now. Let's make use of a calculator. We have gotten this. What I will just do is say I'll raise to power. Okay, let me just say raise to power. That value there is what? 63.383.99968 raised to power what? Raised to power 1 divided by 0.51 bracket close times 0.58 raised to power 0.961 times 288 times 10 times what again? Times 0.88. Go to this. So this is the value we have here. This is what we have. So we have this. So this we now say we say 3153.5 square minus this value, which is 5164555 point 496. 483,058. So this is equal to this. Now let's say the square root of this whole value, the square root of the answer is what? Is 2186.3. So the the pressure at F will be 2000. Let's see. Let me write it down. 2186.3 kilopascal absolute. So we have 2186.3 kilopascal absolute. So this is the pressure at the delivery pressure. We have gotten the delivery pressure at F. So now there's a question again. What pipe diameter is needed for the branching if the delivery pressure required at is 4,000? Wow. So this is the end of this lecture. Thank you for watching till the end. Have a nice day and God bless. Now also do wait to subscribe to my channel so that when I make new video you'll be the first to watch. Thank you and God bless you.